If you have your notebook open, you can write on the top of your notes that it's chapter 3, lesson 7. And today we're going to be talking about the distributive property and using partial quotients. What we're doing today is we are finding area models. That's what we're using, area models to find division. So just like we use area models in our... I'll wait till these talkers are finished with their conversation. Ready? So in chapter 2, we did area models where we broke a number apart, decomposed the number, and made it into hundreds and tens and ones, or tens and ones, and then we multiplied. So today we're going to break that number apart, except for we're going to divide after we break it apart. So same idea. And then we're also going to learn about partial quotients. And partial quotients uses some estimation to do a division problem. So basically in today's lesson, you're going to learn 2 new tools, and that goes along with our essential question that isn't popping up here. But our essential question is having the strategies to do division problems in different ways. So this is just going to be 2 more strategies that you can add to your list of tools that you're going to use to help you when you're dividing. So just like we talked about before, you guys can go if you want. He's left. If you guys would, if this is something that you can use on not every single question, but it will be able to help you with some of the questions. So for some people, they really liked using the area models, and it was an easy way to do some of the division in your head. And sometimes that way is going to work really well. So you can do a lot of division problems in your head and not have to work them all the way out. The partial products, the partial quotient method that I'm going to show you also is going to work for some people, and others may not like it so much. So once we start talking about it, you're going to be able to decide. So when we take our test, or when you take your proficiency test at the end of the trimester, they're not going to ask you to solve something and only tell you one way to solve it. Basically, they're going to give you a division problem, and they're going to ask you to solve it. You're going to use whichever method you like. Some people are going to draw the pictures. Some people are going to do the actual division problem. Some people are going to use the partial quotients, or try to divide it in their head if they can do that, if it's a multiple of 10. So kind of depends on what kind of problem it is and what you like to use the best. Okay? Now that all the lunch helpers are back, have a seat, pull out all of your, I'll talk to you about that later. Pull out all your math materials, get ready to go. We haven't started the lesson yet. You missed the introduction, that's it. So you should be able to catch on to where everybody else is. Okay, so here's your problem of the day. If our new markers, I ordered some new markers and they should be here tomorrow. So if you don't have a marker, a whiteboard marker, just work this problem out in your notes if you don't have a whiteboard marker. So here's the problem. It says that Leah's soccer team has won the last 5 games. Before that, they had only lost 3 games. If they played 9 games total in all, how many total games have they won? So think really hard. Do this one on your own. Don't ask anybody for any help first. We're just going to try to think about it. Okay, I'll give you a couple minutes to think. Well, Leah's soccer team, so they won 5 games. So we know we could do like maybe, I saw some people with some different strategies. Some people making some tally marks. Some people doing something like a win and a loss. So if they won 5 games and they lost 3, but the total has to equal 9. So, okay, so they won the last 5, and before the 5, they lost 3. If they've played a total of 9 games, then how many have they won? So tell me what you just said again, Cameron.
3. They've only 5 plus 3 is 5. Yeah, 5 plus 3 is 8.
So 5 plus 3 is only 8, so there's 1 missing game. Yeah. So this is the part that you should look at, that they only lost 3. So out of all the 9 games that they played, they only lost 3. You're right, it does. It says before that. So before the 5, they only lost 3. So they would need to have played 1 more game that we don't know about. But if they only lost 3 total, then that means they must have won that other game. So that would be another win over here. So in total, they've won 6 games. Some people did it by the total games played was 9, and then they minus the 5, minus the 3 off because they only lost 3, which would mean that the 6 was what was left over. All right, give me a thumbs up if you got 6.
Oh.
Okay, good. So they kind of just left out one missing piece of whether they won or lost that game, but you could. I'll wait till you're done. I can't talk when you're talking because then you can't hear all the important information, right? Right? If you're talking when I'm talking, you don't hear all my important information. Okay. Remember, anytime you hear this voice, you know that it's something important that you should be listening to and paying attention to, okay? Especially today's lesson, remember I'm showing you 2 new tools and you want to learn both of them so that you can decide if either of them work well for you, because you might find something that really makes it click with division today. So, all right, there's our essential question. It's in the wrong order. So, 2 more strategies today to divide numbers. We need to take a few notes. So before we do this, they won't give me any blank slides, so I'm going to draw a line under this, and we're going to take our notes here at the bottom. This is as blank as I could find here, so I need to have some space to be able to show you some notes. So we're not going to look at this question. That's not what we're talking about. We're not doing talk about it. We're just taking some notes. I just needed a blank slide to write on. So look at your notebook. The first thing we're going to learn about is the distributive property. So if I have a question like 248 divided by 2, this is where we're going to have our area models like this. And because the number goes into the hundreds place, I'm going to need 3 sections because I have 3 places in the hundreds place. So I'm going to decompose this number by taking out the hundreds, taking out the tens, and then taking out the ones. So the number I'm dividing by is over here. It's 2. That's the number I'm dividing by. Then I'm going to break up 248 into 200, 40, and 8. Everybody see how I did that? Yes, give me a thumbs up if you saw why I did it that way. I took the hundreds, and that's 200. I took the tens, which is 40, and then I took the 8. Okay, good. So now I'm going to be dividing them in. So I'm going to divide 2 into 200, which is what? How many, Angelina? 2 into 200. 100. So I'm going to write it above. And then I'm going to put a little plus sign because I'm going to add up all these things I'm doing. I'm going to add them all up at the end. So now I'm going to divide 2 into 40. So how many times does 2 fit into 40?
20 times.
20 times. And then the last one is 2 into 8. What is that one?
2 goes into 8 4 times.
4 times. So now I'm going to add them all up. 124. So here's what some people do for these problems. Keep listening. I like how you're getting it, and I could hear that you're getting it. But just keep listening. Some people will go 2 into 2 goes once, 2 into 4 goes twice, 2 into 4 goes 4 times, or 2 into 8 goes 4 times, and then you get 124. The problem comes if all of those numbers are not even numbers. So if all those numbers are not even, then 2 would not have fit in evenly. So just kind of pay attention to that if you were trying to do it in your head without the model. Okay? Question so far? We're going to do another one? Okay. Not looking at this again. Here's another one. 963 divided by 3. So my 3 goes on the outside because that's the number I'm dividing by. And then I'm going to decompose that number into hundreds, tens, and ones. So how much do I have in hundreds? 9 hundreds. How many tens? 60. And how many ones? 3. And now I'm going to divide into each one. So how many times would 3 fit into 900? Karnpreet, what do you think? 200. 300. Now, we're doing that because not because we know our hundreds or anything, or our 900s like that, but we divided 3 into 9 and it goes 3 times, and then we added those 2 zeros. Can you see why this lesson comes after the one where we did this mental math in our head? Because it goes together. And now 3 into 60, same thing. 3 goes into 6 twice. Add the 0. 3 goes into 3 just once. Hold on. I'm going to assume that you're talking because you're telling your neighbor how you got the right answer. Hopefully, not that you're just having a conversation out in the middle of math. So I heard that talking. I'm assuming that that's what that means. All right, let's try another one.
No.
Did you get all this written down? I'll wait a second. Do you see how this goes with, this goes right along with what we did before when we did this with multiplication, except instead of dividing, when we made our area model, we multiplied the numbers and then we got another number. And then we added them all together at the end, just the same way. Okay? Let's look at partial quotients really quick. Partial quotients looks a little different. So here's my question. And for partial quotients, you write it like this, just like you would normally write it. Now, here's where you just really have to pay attention, because to be honest with you, when I taught this one last year, about maybe 2/3 of the class would do it the way I just showed you with the area models. And sorry, coughing. About 1/3 of the class liked the partial quotients. Now, like between Mrs. Reeves and I, Mrs. Reeves really likes to use the partial quotients model. She understood that one, and that one made sense to her, and she likes doing it that way. And I would rather do the distributive property one, the one with the area models, if I had to choose between these two ways. So I'm going to show you the other way, and if you don't really like it, then you're not going to have to use it today. I want you to just think about it, because for some people, it's going to be something that they understand better. All right. So for partial quotients, what we're doing is we're looking at each of the pieces of the number individually, just like we did when we decomposed the number before, and we would decompose it into 600, 50, and 4. We're pretty much doing the same thing, except it just looks different the way that we're writing it. So we're going to see how many times we think 3 can fit into 600. How many times can 3 fit into 600? Malachias, how many times? 200, because 3 times 200 equals 600. So then underneath, you write a 600, and you subtract it. So over here where I put the parentheses on the side, that's kind of like our thinking. That's me thinking, okay? That's why I put those in parentheses. So we multiply by 200. Malachias said you multiply it by 200. Now we get 54. That's what we have left. So now we're going to use some estimation, kind of like what we learned how to do a couple days ago. So I'm going to think of how many times I think 3 can fit into 54. So think about it. Think about what numbers you might use. Usually we're going to be thinking of powers of 10, because we're not doing the actual, before I ask for help, I'm going to kind of walk you through this one, because some people are going to tell me the exact answer of how many times 3 fits into 54, and it's because you're following the standard algorithm. That's not really what this is about. This is about using estimation to help you. So if I say 3 times 10, because remember I'm using powers of 10. I told you you're thinking of powers of 10. 3 times 20, which is the next power of 10, would give me 60, and that's too much. So 3 times 10 is going to be the closest I can get to that, which is 30. So the number that I multiplied by over here was 10. And then I have 24 left. And now I'm going to say that 3 times 8 gives me 24. And that's what I'm thinking over here to the side. And then I get 8 there. So now I have 200 plus 10 plus 8. So my final answer is 218. Hold on. Listen very carefully. I think I prefaced this lesson, I know I did, by saying some people don't want to use these tools. And if you don't want to use these tools, then after today's lesson, you don't have to use them. Today, hold on. How many people do we have in our class? 33. That's 33 different brains, 33 different ways of learning, 33 people who have a different way of thinking. Everybody doesn't think like you do. Everybody doesn't. So sometimes people have other ways of thinking. Just like I told you, between Mrs. Reeves and I, If we were going to choose which way we would like to use, she chooses one way, I choose the other. And that's okay. We both end up with the same answer. That's why I told you at the very beginning of this lesson that for the math proficiency or even the math test for chapter 3 that we'll be taking soon, I'm not going to ask you to solve it in a certain way. I'm just going to ask you to solve it. The whole purpose of chapter 3 is to show you 6 or 7 different ways that you can think of these math problems. And for some people, long division is really hard. For a lot of people, long division is really hard. And tomorrow we're going to get started with learning how to do long division with bigger numbers. I'm glad you're excited. Hold on. Shh. Listen, I'm trying to explain why we're doing this because that's the question that I'm hearing. So the reason why I'm showing you these ways, girls, save your conversation for recess, okay? Anything you're talking about, save it for recess. Sean, save your conversation for recess. So the reason why I'm showing you all these ways is because it allows you to be able to choose which way works for you. So just because a way doesn't work for him and a way doesn't work for you and a different way doesn't work for him, the beauty of it is they can all three choose a different way to solve the problem and all get the same answer, and it is up to you to solve it the way that you... Now, if I was your one-on-one personal tutor and we got to this lesson and you said, I don't like this way, I would say, okay, and we'd skip it and we'd go to a way that worked just for you. But because there's 33 people all listening to this math lesson, I show you all the ways, because that way everybody gets to pick and choose the ways that work for them. Okay? So sometimes, like I was trying to say, long division is really hard. And so a lot of times what it is that people don't understand fully what they're doing, and that's the reason why it's so hard. So they get to the divide, multiply, subtract, bring down, and then they raise their hand and say, I don't know what to do next. By me showing you some of these other ways, like this is really using estimation. That's what we did to solve this, is we're using estimation to help us. So that's what you're doing when you're solving a long division question. You're trying to estimate to see how many times it goes in. We don't know how many times 3 goes into 654 without estimating. All right, so please don't, the thing that I don't like to hear with this lesson is when people start to say, I don't want to do this, and this way is dumb, and stuff like that, because when someone says that, and someone next to you actually wants to use this method, it shouldn't mean anything to you if somebody next to you wants to use this method. If you don't want to use it after today, then you don't have to. But some people, it's going to help them to understand a little bit deeper. That's what this is about. It's understanding what we're doing. We're first dividing into the hundreds, which is why we pulled out 600 to divide into. Then we go just and divide into the tens. That's what the bring down is about. And then we divide into the ones, which is what the second bring down would be about. Okay? So, and you know how yesterday when we were drawing the pictures, and if you tried to divide a 10 amongst 3 circles, you would have to break it up into ones. That's renaming, regrouping. That's what we're doing on here. So it all is supposed to go together to help you further understand how to do division. If you're just trying to memorize the steps, sometimes that works, and sometimes you get stuck because you aren't sure what to do next. Okay, so I want you to think of which way works best for you, and then before we start today's assignment, I'll give you some direction on how I want you to solve some of these once you get started with the lesson today. So look over at your Malachias. What's your question? Okay, so he's saying that he did long division on that one and got the same things, and you are going to. So the point is, it's a bunch of different ways to all get to the same answer. Like if, I'll wait for all these people to sit down so that everybody's listening carefully. Not right this second. Ready yet? No? Yeah? Okay, good. So, one person in the room may want to draw pictures. if I asked one person in the room, if I gave you a question and said, I want one of you to draw a picture, I want one of you to do the standard algorithm and solve the problem, I want somebody else to do partial quotients, and I want someone else to use the distributive property, all 4 of those people should get the same exact answer. That's the point. The point is that no matter which way you choose, you're going to get the same answer. It's all personal preference. When it comes to the test, it's what you prefer and how you prefer to solve the problem, okay? So please know that for today's lesson, there's a couple of ways here, and I don't think everybody's going to love both ways. I think that you're going to pick which way works best for you. So look at your paper, the draw it page. This one is using the distributive property. You're going to have to move if you can't stop talking. That was the deal, right? Okay. If you can't be successful here, you're going to have to move someplace else.
I can be successful.
This one says, Jessie has 369 beads to split evenly among 3 necklaces. How many beads can Jessie put on each necklace? So we're going to split up 369 by 360 and 9. So we are decomposing this number into 360 and 9. Now we're going to divide each section by 3. So 3 goes into 300 100 times. 3 goes into 60 20 times. And 3 goes into 9 3 times. Pay attention. Write everything in. If I have to wait again, it's got to come from your recess because we're going to run out of time. Okay, so if we add up all of those parts, we have 100 plus 20 plus 3 would give you a total of 123. So Jessie can put 123 beads on each necklace. And if you multiplied, if you multiply 123 and you multiply it by 3, then you should get 369. And that is a really quick way to check your division answer. So multiplying is a really quick way to check your division answer. You multiply the divisor, which is the number that's on the outside, by the quotient, which is the answer, and that should give you the dividend, which is the number underneath the bar. All right, let's look at example number 2. Example number 2 is using partial quotients. So look at this example as we fill it in. There are 738 students in Manuel's school. There are 6 grade levels in his school. If each grade has the same number of students, how many students are in the 5th grade? So you're doing 6 divided into 738 because each grade has the same number of students. So let's read together what it says here for number 1 because this is going to help with the partial quotients model. Number 1 says, first, divide the hundreds. So we're trying to get as close to 600 as we can using a multiple of 10 to try to get up to 700. So 6 times 100 would be 600. Then we have 138 left. So you should be looking at the partial quotient over there on the side. So 100 is our partial quotient. Then we're going to subtract 600 from 738, just like we do on a regular division problem, and we get 138. Now we're trying to think of something times 6 that we can something we can multiply 6 by using our head, because this is all should be done kind of more in your head. So what can you 120 is close to 138 and is compatible with 6. So if we divide 6 into 120, what would we get? What would we get?
18.
We would get just 20. 6 goes into 12 twice, right? And then you add the 0 on. So 20 would be your next partial quotient. Basically, the numbers that you're writing on the side are going to be a number that goes to the hundreds place, a number that goes to the tens place, and then a number that goes to the ones place. So then when you subtract, what's left is 18, and 6 goes into 18, we know 3 times. So then your final answer would be 123. Because you're basically adding up these little partial quotients over here on the
Same
side.
answer as the first one.
Yeah. I think what they're trying to do is just show you just what I was trying to tell you, how you can get the same answer different. Yep.
All they did was multiply both numbers by 2. That's all they did. Because 3 times 2 is 6.
Yes, you're right. So if you were trying to fill the rest of this in, we already filled in the chart over here, and we had 100, 20, and 3. So if we divide 18 by 6, it would be a 3 as your partial quotient. You're adding up 100 plus 20 plus 3, and you get 123. So there are 123 students in the 5th grade. And if you multiply 123 by 6, you'll get 738. Just like I said before, multiplication is a good way to check your division. Now, if you look over at the assignment portion, we're gonna skip past the talk about it and go to the practice page, because I want to show you some of the directions. This says use the distributive property to draw some diagrams. Do you see those directions? Okay, now I want you to look down a little bit onto the next part where it says use partial quotients. Here's my directions. I'm going to revise the directions because just like I said at the beginning of this lesson, on a test I'm not going to force you to use one way. I would like you to choose between the 2 ways that we learned today, the way that works best for you, and then I want you to use that way to solve all of the problems. So I'm not going to force you to use a way that you don't understand. So if one of those ways, hopefully one of the 2 ways we talked about today made some sense, I want you to take the way that you like the best, the way that you would choose, and I want you to choose to solve all the problems in that way. So even if the directions say to use partial quotients and you like using distributive property, then go ahead and use distributive property. The main thing is that you're dividing and you're getting the same answer as someone who would have used partial quotients. I need you to use one of these 2 ways. So I am letting you choose, but I'm letting you choose to an extent to where because I do need you to know what partial quotients are, and I need you to know what hold on. I got a lot of arguers today. Can I show you some more examples? Which way would you like some more examples on? Because I'm happy to show you some more examples. Okay, so I'm not going to let you just divide, and I know that's frustrating, but I want you to use one of these 2 ways. I want you to be able to decompose numbers, which is what we're doing. So, hold on. Part of the standards that I have to teach you is to be able to decompose numbers. And if I just let you go forward and do divide, multiply, subtract, bring down, you're never decomposing a number, and you don't know how to take the numbers apart. So, that's what we're practicing today, is decomposing numbers. Both of these ways, partial quotients and distributive property, both helps you learn how to decompose numbers. I would like you to choose one of those 2 ways. You get to pick which way works best for you. So read the directions, and even if the directions say a different way, you can choose a way that works best for you.